This is the third MES2 online class for 9th standard of Berimbau Business Academy. We are continuing the same exercise 10.4, and today in this class we will work out two textual questions. Here the first question is question number 22. A vertical tower stands on a horizontal plane and is surmounted by a vertical flagstaff of height 8. At a point on the plane, the angle of elevation of the bottom of the flagstaff is alpha and that of the top of the flagstaff is beta. Prove that height of the tower is 8 tan alpha divided by tan beta minus tan alpha. Here is the question. Now let's draw figure and try to understand more about this question. A vertical tower stands on a horizontal plane and is surmounted by a vertical flagstaff of 8h. Now look at a figure here. BC, you can see BC. Let BC be the tower, and on top of the tower there is a flagstaff which is represented by CD, and the height of this CD is 8. Now tower, on top of tower there is a flagstaff, and now the observer is on the plane which is on the ground level with the tower. Let's say A is the point of observation. Now let BC and CD represent the tower and the flagstaff respectively. BC is the tower, CD is the flagstaff. A be the point of observation in the plane. A is the point where observation is observing both top and bottom of the flagstaff. And let's see at the question again. Look at a point on the plane, the angle of elevation of the bottom of the flagstaff is alpha. Now looking from this point A on the ground level, observer is looking at the bottom of flagstaff. Flagstaff is CD, C is the bottom of flagstaff, D is the top of flagstaff. So from the point A, looking at the bottom of flagstaff, bottom which is D, or bottom of flagstaff is the top of tower. Looking at this, the angle of elevation is alpha. This angle is alpha. Again, from the same point A, looking at the top of the flagstaff which is D, if observer is looking at the top of this flagstaff, the angle of elevation is beta. So this angle, big angle, is beta. Then we are asked to prove that height of the tower, which is represented by BC. We have to show that the height of this tower BC is 8 tan alpha divided by tan beta minus tan alpha. So just like the previous question we did, here we get two right triangles in the figure. So we will consider two right triangles and try to get two equations from two right triangles. Now the first right triangle we consider is right triangle ABC. Look at ABC, the smaller triangle. In this triangle, again, let's express in terms of tan. For this triangle ABC, here we have angle A, which is alpha, and for this angle alpha, BC is opposite sides, AB is adjacent sides. So we write BC by AB opposite by adjacent is equal to tan of angle alpha. Then cross multiplying, we get AB into tan alpha is equal to BC, and from here we express for AB. Then AB is equal to BC divided by tan alpha. Tan alpha and AB are multiplying. If we transfer this tan alpha into right hand side, tan alpha become divide. So this is the first equation. Then for the next equation, let's consider another triangle. There is triangle ABD. So in this triangle, the angle is beta, which is angle A. For this beta, opposite side is BD, and adjacent the same size AB. So we write in triangle ABD, BD by AB, which is opposite by adjacent, is equal to tan beta. Again, cross multiplying AB tan beta is equal to BD, and we express for AB is equal to, now we write BD as BC plus 8. BC plus 8 divided by tan beta. How do you write BD as BC plus 8? BD, this is the total height of tower and flagstaff, so we can write BD as BC plus CD, and the length of CD is 8. So we replace BD by BC plus 8. So that is how we get the second equation. Now if you observe at these two equations, you can see left hand side AB, here also left hand side AB, left hand side of equation 1 and equation number 2 are equal. So we can directly make the right hand side 2 equal. From equation 1 and 2 we get right side is equal to right side, equation 1 and 2 right hand side. From here let's cross multiply. BC numerator will multiply with denominator right hand side, that is tan beta, so BC tan beta is equal to tan alpha will multiply with BC and also tan alpha with 8. So we multiply BC and tan alpha, we get BC tan alpha, again 8 and tan alpha, 8 tan alpha. Then you can see there are two terms having BC. Now we bring the terms having BC from right side to left. Then this BC tan alpha is plus right hand side, this transfer to left, so it becomes minus. Again from these two terms we have BC common, so we take BC common, then tan alpha minus tan alpha. Then again we want to express for BC, so we write BC left side, tan beta minus tan alpha is transferred to right hand side, then it becomes divide. Then you can see we get expression for BC. BC is equal to h tan alpha divided by tan beta minus tan alpha. What is BC? If we go back to the question, we have taken here BC to be tar. And if you look at the figure 2, BC represent tar. So now finally we get height of the tar, which is represented by BC, is equal to this. This is what is asked in the question. Thus height of the tar is h tan alpha divided by tan beta minus tan alpha. So that is how we do this textual question number 22. Then for today, let's do one more question. The next question is textual question number 19. This is one of the good question. What I mean is one of the expected question. Question number 19. Let's see the question. As observed from the top of a lighthouse 100 meters above the water level, the angle of depression of two ships are 30 degree and 45 degree. If one ship is to the north and the other to the to the east of the lighthouse, find the distance between the two ships. So for this condition, it's not possible to draw the exact diagram on the paper. So let's try to understand first the real situation of this question. Look at this small model that I made for you. Now there is the exact condition. See, let's consider this to be lighthouse, and now one ship is to the north and another ship is to the east. This is lighthouse. You can see this lighthouse, and one ship is to the east of lighthouse and another ship is to the north. Can you see this like this? North one ship, east one ship, and the height of this lighthouse is 100 meters. Now we are asked to find what is the distance between two ships. Ship at north direction of the lighthouse and ship at the east of lighthouse. We have to find their distance, represented by this. We have to find this distance. Before that, we will see here we have three right triangles. Look here, there is lighthouse, and let this be the position of ship to the north of the lighthouse. Then this ship and distance of this lighthouse and distance of ship is perpendicular. You can see right angle. So we have here one right triangle, and another one. Let's see, lighthouse, here ship at the east. Then again, distance of this ship from the lighthouse and lighthouse are also perpendicular. We have another right triangle. And the third one is, you can see, distance of one ship and distance of another ship, and they are also perpendicular. So we have another right triangle. Altogether we have three right triangles. And finally we are to find this distance between two ships. So since this exact figure is not possible to be drawn, we draw like this. Here AV is lighthouse, and D is the position of one ship, C is the position of another ship, and this here we have one right triangle, here we have two right triangles, and altogether we have three right triangles. Then we have to find this distance between this is the distance of one ship from the lighthouse. This BC gives the distance of another ship from the lighthouse, and the distance between these two ships, we have to find this length. Again, here also we have another right triangle. You look at the figure, there is the right triangle, the last right triangle, and from this last right triangle we have to find the distance between two ships, which is hypotenuse of the right triangle. Then let's start. I hope you at least you can visualize the real situation of this question. Let AV be the lighthouse, C and D be the two ships to the east and the north. AB is lighthouse here, which is 100-meter high. C and D are the position of two ships. Let C be to the east and D be to the north. Then angle of depression are given 45 and 30. So this angle 45, this angle is 30. Then the first right triangle we consider for this question is right triangle ABC. Right triangle ABC. Yeah, right triangle, this angle is 90. So in this right triangle we will try to get equation for BC. Again, we write for tan theta. In this right triangle, this is 30 degree. So for this angle, AB is hypotenuse. AB is opposite and BC is adjacent. We write AB by BC, opposite by adjacent is equal to tan of 30 degree. Tan 30 degree. Tan 30 degree value is 1 by root 3 and the value of AB is 100. So from here we get expression for BC by cross multiplying. BC is 100 root 3. There's equation number 1. And for the second equation, we will consider the second right triangle, which is ABD. For this right triangle, here angle is 45. So for this 45, AB is opposite, BD is adjacent. So the next right triangle we consider is ABD. AB by BD, opposite by adjacent. We have angle 45, so we write in terms of tan. Tan 45 value is 1, cross multiplying we get BD value is 100. There is a second equation. Then now the third condition is the third right triangle to be considered is triangle BCD. This is also right triangle and this angle is 90, so we have to find the size CD, which gives a distance between two ships. So for this right triangle BCD, CD is hypotenuse. For this we have this BD length, we have BC length from equation 1 and 2. So the third triangle we consider is in right triangle BCD by Pythagoras theorem, CD hypotenuse is equal to BC square plus BD square. We want to find CD length, so we remove square from left side and right side comes under square root. And the value of this BC in equation 1, it is 100 root 3. BD 100, so we put the value 100 root 3 whole square, then 100 square. You can see 100 root 3 whole square is 100 root 3 into 100 root 3. 100 into 100 is 10,000. Root 3 into root 3 is 3. 10,000 into 3 is 30,000. Like that, 100 square is 10,000. So adding these two, 30,000 and 10,000, we get 40,000. And the square root of 40,000, square root of 4 is 2 and square root of 40 is 2 zeros. We get 200 meter. What is this 200 meter? There is the length of CD, and if you look at the figure, CD is nothing but this is the distance between two ships at C and at D. So we conclude thus distance between the two ships is 200 meter. So these are the question for today.